Here we are again. We have Pre-Calc Lesson 33. Quadrilaterals, properties of parallelograms, types of parallelograms, conditions for parallelograms, and trapezoids. So let's talk about quadrilaterals. Okay, quadrilaterals is a four-sided polygon. Okay, and there are three categories. One where no sides are parallel. One where exactly two sides are parallel. That's a trapezoid. And one where both pairs of sides are parallel, and that is a parallelogram, hence the title. Okay, now let's talk about properties of parallelograms. Okay, both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. The diagonals bisect each other. And any pair of consecutive angles is supplementary. Okay, so let me draw a parallelogram for you, and we can label these things. Okay, if this was A, B, C, D, okay, the opposite sides are equal, so AB is congruent to CD, and BC is congruent to AD. The opposite angles are congruent, so this angle is congruent to this angle is congruent to this angle. The diagonals bisect each other, so I'm going to redraw it so we can have a good visual. If this is my diagonal here, they bisect each other, meaning this segment and this segment are equal. This segment and this segment are equal. Okay, and if any pair of consecutive angles is supplementary, so angle A plus angle D equals 180. Okay, all right, now let's do a quick example with parallelograms. We want to prove that the opposite sides of a parallelogram are congruent. So if I have this parallelogram, I want to prove that AB is congruent to CD and BC is congruent to AD. Okay, so statement, reason. All right, so my first statement is ABCD is a parallelogram, and that's my given. Okay, now number two, I can say that BC is parallel to AD, and AB is parallel to CD, definition of parallelogram. Okay, now I'm going to draw a diagonal here. I'm going to label this as angles 1, 2, 3, and 4, just for easy reference. And I can say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, because they are alternate interior angles. We remember that those are always going to come back. We know that angle B is congruent to angle D, definition of parallelogram, right? They're opposite. So let me start to label. These are congruent. I know that these are congruent. I know that these are congruent. And I know that AC is congruent to AC by reflexive. So I can say triangle ABC is congruent to triangle ADC by angle, 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 side. And then I can say that AB is congruent to CD and BC is congruent to AD, CP, CTC. So there you go. That is using parallelograms, and that was a little bit of review for you on proofs. All right, so let's move on and talk about types of parallelograms. You're going to be tired of writing parallelograms, so I know I am. We have a rectangle. A rectangle is a parallelogram whose angle, or one of whose angle, is a right angle. Right? We know that this is true. These angles are right angles. Okay? A rhombus is a parallelogram in which two consecutive sides are congruent. So here's a rhombus. We typically see it like this. It tells me that these sides and these sides are congruent. Okay. Now all of these have all the same properties of parallelograms. These are just more definitive properties. And square is a parallelogram that is both a rhombus and a rectangle. Draw the diagonals, might make it easier to see. Okay? Now, let's get properties of rectangles. Has all the properties of a parallelogram. Okay, all angles are right angles, and the diagonals are congruent. Okay, let's get all of the properties of a rhombi. It has all properties of a parallelogram. All sides are congruent. The diagonals are perpendicular to each other. Their diagonals bisect the angles whose vertices they connect. And intersecting diagonals, they divide the rhombus into four congruent right triangles. And let's get all the definitions of a square. Square has all properties of rectangles. They have all properties of rhombi. And their diagonals form four congruent isosceles triangles. Now, all of these are really important because you need to know all of these facts. We're going to do proofs with them. Okay? You might also be given questions that ask you to identify which type of parallelogram we're talking about. All right, now let's define conditions for a quadrilateral to be a parallelogram. Okay, 1, both pairs of opposite sides are congruent. to one pair of opposite sides is congruent and parallel. The diagonals bisect each other. And both pairs of opposite angles are equal. Okay? All right. So after all of that, let's do an example. Okay? Now, the example says, given a parallelogram, whose diagonals are congruent, which of the following must be true? A, all four sides have the same length. B, the diagonals are perpendicular bisectors of each other. Or C, all four angles are right angles. Okay? So, given a parallelogram whose diagonals are congruent, which the following must be true: all four sides have the same length, the diagonals are perpendicular bisectors of each other, or all four angles are right angles. And we know that if our diagonals are congruent, we are talking about a rectangle. And since that is true, C is the only one that accurately describes a rectangle. All right, let's move on to trapezoids. Okay, trapezoids are quadrilaterals with exactly one pair of parallel sides. Okay, we have bases, which are our parallel sides. So if you didn't know, this is a trapezoid. Okay, we have the median, which is the segment connecting the midpoints of our legs. So in this diagram, this is a base, this is a base, this is a leg, this is a leg, and that's my median. And our altitude connects the bases and is perpendicular to one of them. Okay, now more properties of a trapezoid. The area is 1/2 the height times base 1 plus base 2. And the median is parallel to both bases. And the formula for median, L, is 1/2 base 1 plus base 2. Okay? All right, I know it's a lot of writing today, but we're not done. We can have an isosceles trapezoid where the non-parallel sides have equal length. The lower base angles are congruent. The upper base angles are congruent. The diagonals are congruent. And any lower base angle is supplementary to any upper base angle. Okay, so all of these definitions are stuff that we are going to use to be able to solve trapezoids. So let's do some examples. Okay, we have this trapezoid here. This is x, tells me that my height is 10, and this is 2x plus 8. And it tells me that the area is 175 centimeters squared. Find x. Now we know that what I can do here, I can actually do two things. This is actually kind of sneaky. I can divide it into two triangles. Triangle 1 and triangle 2. And the area of the trapezoid is the area of 1 plus the area of 2. So the area of my 1 is 1/2, my base is x, my height is 10. The area of the other is 1/2 my base times my height. Now, all of this actually is our same formula. The area of a trapezoid is 1/2 height times base 1 plus base 2, which in this case 1/2 my height is 10 and my base 1 plus my base 2. It's the same thing. So we really get our formula for our trapezoid, area of a trapezoid, if we divide our trapezoid into two different triangles. So let's solve this. This gives me 5 times 3x plus 8, which gives me 15x plus 40. And we know that the area equals 175. So then I get, if I divide everything by 5, I could do that. Or you could subtract 40 over, so 135 is 15x. Then we get x is 9. And we label our units. This is in centimeters. Okay. Let's do another example. Here's this trapezoid. This is 2x plus 2, and my median, which is 4x plus 1. And I have 7x minus 2. I want to find x. Now, we know the formula for the area of the median. L is 1/2 base 1 plus base 2. So my L in this case is 4x plus 1 is 1/2 times 2x plus 2 plus 7x minus 2. All you have to do is memorize the formula and plug it in. Now I'm going to multiply everything by 2, so I get 8x plus 2 equals 9x plus 2 minus 2 cancel. So then 2 equals x. Ta-da! So you need to memorize your formulas and your properties for trapezoids, parallelograms, quadrilaterals, squares, rectangles, rhombi, all of the above, okay? But for now, these are all the examples we're going to do with those. You will do much more in your homework tomorrow. Have a good